For this video, we're going to look at NFPA 70E 130.8M, and these are the requirements for reclosing circuits after protective device operation. So here's the full statement. But without reading the whole thing, to sum it up, basically, if you have a circuit breaker or a fuse and it opens a circuit, you can't just reset the breaker or replace the fuse because there might be a fault present. And if you just reset and re-energize, this can be a very dangerous situation. But if you notice here, there's an exception to this. And the exception is that if the circuit opened because of an overload rather than a fault condition, you don't have to examine the circuit first. It'll still be a good practice to know that it opened because of an overload and verify that. But if you know that, you don't have to examine the circuit. So let's look at an example and see why this is a very important item. Here we have a picture of a motor control center bucket or an MCC bucket. The wires at the top up here connect to the MCC bus, and the wires for the motor connect down here to terminals T1, T2, and T3. So let's just say that this bucket was installed in an MCC section and it was energized, the motor's running, everything's fine, everyone's happy. But all of a sudden the motor stops running and now you have to investigate. What would you do? Well, if you went to this bucket, more than likely one of two things occurred. The first thing that might have happened was a circuit breaker trip. So in this case, we have a 50 amp circuit breaker. It's connected with the mechanical linkage to this handle, so that way you can operate it with the door closed. So typically, if this breaker tripped, instead of being in the off position, down, or all the way up in the on position, it might be in the middle, right here. And then you have to turn it off and then back on to reset it. But we mentioned that this would be very serious if a circuit breaker trips, because it meant that there was a fault either at the motor or in the cables going to the motor. So we wouldn't just want to reset that. We would get someone to investigate first. The second condition would be that the overload tripped the circuit. And so over here we have our overload block right here. And then there's this white reset button that you can push the reset button. Hopefully you can do it with the door closed to reset. And that would be, again, if the motor simply was overloaded, after a few seconds, it would open the circuit breaker. So as long as you knew that that was the case, you can reset that without further investigation. But back to the circuit breaker. Why can we say if the breaker trips is such a serious condition indicating a fault? Well, right here, you can see this little white label. It's kind of hard to read, but I can tell you there's some letters and they correspond to different amperages that will flow through the breaker, and that's where it would trip. So the first letter is A. It corresponds to 150 amps. B is 250 amps, all the way down to H, which is 500 amps. So let's see if 500 amps flowing through this circuit, if that's a serious condition or not. So the next slide, we're going to show this being modeled. Let's investigate. This is a model of the same MCC bucket. Here's the 50 amp breaker, the overload, the cables going down to the 25 horsepower motor that we've selected. So let's look at the time current curves, or the TCC, for this circuit. We have this already modeled. Okay. So this is what the curve, the blue line here, this blue curve is what the current for the motor will look like. And on this curve, you can see down here, you'll see the amperage and the time change depending on the point of the curve that we're on. So once the motor is up to speed and is running, the full load amps for this motor is about 30 amps. So you see that depicted here. That's about 553 seconds. But when the motor first starts, since the shaft is not turning yet, it draws a large inrush of current. And depending on the motor, that could be anywhere from 6 to 15 times the full load amperage of the motor. But in this case, we have it modeled at 6.5 times 30 amps. That's the full load of the motor. So 6.5 times that is 195 amps, or let's just round up, say 200 amps. So when the motor first starts, it sees this large amount of current, 200 amps. It'll stay that way for a few seconds. And then after a few seconds, the current will drop down, probably down here until you start to load up the motor. But worst case, it'll be about 30 amps, worst case. So really, if you look at it, this motor should never draw more than 200 amps. If it does, something's wrong. There's a fault on the wires on the motor, and we have to have the circuit breaker to open that circuit very quickly. And that's exactly what this black line is for. This is the curve of the circuit breaker, our 50 amp circuit breaker. But remember, we showed in the previous slide that there were letters that correspond to different amperages of where the breaker would open the circuit. So if we see here, A, this is what the curve would look like. And we mentioned on a previous slide that A corresponded to about 150 amps. So you see that here is really the midpoint. You can see in the middle of this curve is about 150 amps. So that would be too sensitive, because as soon as the motor started, let's change the colors. This is our 200 amps here. As soon as it starts, it would be in the region of the breaker trip curve. So that's where you would start the motor and immediately the breaker would trip. So that's too sensitive. So instead of setting it at A, let's try B. Okay, B, that was 250 amps. That's still too sensitive. C is right there, but that's really, really close. Let's try maybe D, or maybe even E is possibly where we would set that circuit breaker. So now we're protected from short circuit event. Because if the short circuit, let's say it was 1,000 amps, as soon as it saw that amount of current, it would trip. The circuit breaker would trip because it would touch that part of the curve immediately. But under normal conditions, again, worst case is about 200 amps. It's not going to trip because of that black curve of the circuit breaker. But we mentioned there was another component, the overload. So that's this green curve here. And the overload is set, we mentioned when the motor is not fully loaded, it will be in the region back here. But if it's fully loaded, it'll be about 30 amps. So with the motor running, if it started to draw more than 30 amps, let's say 33 amps, 35, 36, we overloaded the motor. After a few seconds, it would touch this green region and then open the circuit, but that was an overload condition. So again, this is just showing the difference between the overload when it opens the circuit. That's for, we just overloaded the motor, versus the serious condition. And again, that would be maybe 30 amps or so. But if we're way back here, 1,000, 3,000 amps, that's a faulted condition, because our motor should never see that amount of current.